Hello, in this video I'm going to talk about the acetoacetic ester synthesis. And if you're comfortable with malonic ester synthesis, you're really 80 to 90% there in terms of being able to do the acetoacetic ester synthesis, because it's going to be the same type of steps. You're going to have alkylations, you're going to have acid catalyzed hydrolysis, decarboxylation and tautomerization. All those steps are going to happen. It's just they're happening on a different substrate. Okay, so let me give you a little overview and then I'll give an example or two. So malonic ester, we have this diethyl ester. Okay, subject it to about a bunch of steps and we get to this alpha alkylated carboxylic acid. So we're losing that chunk there, and we're turning this into a hydrogen, and we're alkylating that middle carbon. Okay, acetoacetic ester synthesis is going to be almost the same, except if you look at what's different between these molecules, we've replaced this OET group with a methyl group. Okay, we've gone from an ethyl ester to a ketone on this side. Okay, and so this ketone group is preserved here. Okay, we alkylate that center carbon, and on the left this gets hydrolyzed and decarboxylated. Okay, so you can see they're almost similar things going on. It's just instead of making an alpha alkylated carboxylic acid, we're making an alpha alkylated methyl ketone. Okay, so let's look at an example here, and I'll kind of break it down into the different steps. All right, so I'm going to start out here with my acetoacetic ester. Such a funny name. Okay, so there's my acetoacetic ester. I'm only going to alkylate it once. So I'm going to use sodium methoxide, which would be the first step. I'm going to alkylate it. Maybe I'll do a 4-carbon alkyl bromide. Then we have H3O+, H2O, and heat. And that's ultimately going to get me, here's my methyl ketone. One, two, three, four. All right. This here's the new CC bond. Okay, so let me break it down for how we form that. Okay, again, this is gonna be the same as what we did with malonic ester synthesis, but I think it's a good review here. Okay. So first step, we have sodium methoxide. The sodium is a spectator ion. The ethoxide is doing all the work here. We're going to do a proton transfer. Which makes our enolate, which is highly resonance stabilized. We have 2 adjacent carbonyls. Okay, there's 2 electrons there. Ooh, that's a 3. Just take my word for it. Okay, and then we're gonna do so this was a proton transfer. Then we take our enolate nucleophile. We do an SN2 reaction. Ugh. One, two, three, four. Okay, great. And then we're going to do an acid catalyzed ester hydrolysis. H3O plus H2O. That turns our ethyl ester into a carboxylic acid. Okay, like so. There's our carboxylic acid. And now remember, this is multiple elementary steps here. Okay, I'm not showing the full mechanism. I'm just kind of showing you in general what's going on. This is a 6-step mechanism to do that hydrolysis. Okay, I'm going to redraw this. So I'm going to say this equals, and then I'm going to rotate around this CC bond here. Okay. So there's no reaction happening here. I'm just rotating our view of the molecule. And I'm doing that to bring this hydrogen closer here. Okay. And then I'm going to draw 3 curved arrows for the decarboxylation. I could go clockwise or counterclockwise, it doesn't matter. I had to think about that for a little bit, a little while ago, just to make sure. It's like, does it matter? No, it doesn't. Okay. So when we do that, we're going to make carbon dioxide plus the enol form of our final product. Okay, there's the enol. And we usually say that heat's involved with this decarboxylation. Okay. And then that enol we can undergo acid catalyzed hydrolysis, or not, tautomerization. Okay, that's 2 proton transfers that happen. And 1, 2, 3, 4. Okay, and there we go. I think I've got time. I could give you a couple more examples, so I'll try to do that. Let's see here. Okay, and again, acetoacetic ester synthesis means not that we're making acetoacetic ester, but that we're using it in our synthesis. Okay, so we're going to take that. Sodium methoxide. Okay. Use a 3-carbon, another sodium methoxide, and trying to be original here, 5 carbons, and then H3O plus, H2O, heat. Okay, so we're going to do a double alkylation followed by a hydrolysis. Okay. Oops, something's wrong with that. Can you see what's wrong? This is not a malonic ester synthesis. Okay, that's it. Should be a CH3 group. Okay, so I alkylated with a propyl group, then I alkylated with a pentyl group, 5 carbons, and then we did our hydrolysis, decarboxylation, and tautomerization to get to that product. All right, so that is going to conclude this lecture on the acetoacetic ester synthesis. I think saying that may be the hardest part of this. And thanks for watching.